Hello everyone. So it's good to see you all again, once again, followed by the P block elements too. And in this session, we are going to look into the mechanisms which is present in the unit 12, which is called Aldol condensation. In the forthcoming video, in the upcoming video, you are all going to look each and every mechanism as a single video so that you can just have a look at it while traveling for a period of 10 minutes. So our aim is to just convey the content as quick as possible in a proper way with a better understanding. So the initiative have been taken and will be dealing with the very important reaction mechanisms as one video for one mechanism for a period of 10 minutes. So this is the initiative. So once again I welcome you all. In this session we are going to look into the Aldol condensation, mechanism of Aldol condensation. So which is present in the unit 12, carbonyl compound and the carboxylic acid. See this what is the aldol condensation? When I say aldol, we have a functional group of both aldehyde and alcohol. So combinedly it is called as an aldol. So that's the meaning of this name. Then how do you get this aldol? Either by treating with by performing the reaction between the aldehydes or between ketone or with an aldehyde or ketone, so that you will be able to find the aldol as a product. Okay, now the question comes, whether all the aldehyde undergoes this aldol condensation? No, it is not so. Let me take this basic aldehyde, formaldehyde. Right? So we have a carbon over here, we have only one carbon, that's the functional group. The carbon which is present immediate next to the functional group is called as an alpha carbon. We do not have an alpha carbon here because we have only one carbon and that carbon is acting as a functional group. We do not have any more carbon. Suppose if an hydrogen is replaced by CH3 here, so this is the functional group and this carbon is called as an alpha carbon. See, the hydrogen which is present in the alpha carbon is called as an alpha hydrogen. Any aldehyde which has alpha hydrogen will undergo this aldol condensation. Here we do not have the alpha hydrogen, so formaldehyde will not undergo this aldol condensation, but acetaldehyde itself will undergo the aldol condensation so easily, which means two molecules of an acetaldehyde itself will undergo this aldol condensation so that the product can be formed. So this is the condition. So the reaction happens between dilute NaOH. So it happens in a basic medium. So this is what regarding this aldol condensation. Okay. See, the aldol condensation happens between the two aldehyde or the aldehyde and a ketone. We call it as a crossed aldol condensation, or between two different aldehyde we call this as a crossed aldol also. Okay. See this aldol, we are getting a product called aldol. It's an beta hydroxy aldehyde. So that's the compound we'll be getting here. The condition is that the aldehyde must have an alpha hydrogen here, so that's the very important condition. Secondly, the general reaction for this mechanism. The general reaction for this mechanism includes CH3, C double bond O, H, and one more. CH3, CHO, I will write in this way, CH2, bond H, CHO. The reaction takes place with the presence of dilute NaOH. So both are acetaldehyde. What happens here? See, this carbon will take up the electron of the hydrogen there, will take up the electron of hydrogen and goes and approach this carbon. Thereby, a bond is formed between these two carbon. So the valency of this carbon becomes 5. So this bond will shift. This oxygen will take up the hydrogen and forms as OH. So your product is, to start with, CH3. We have got C. Here it is O. Along with this hydrogen it is OH. On the right side we have H. On the top we have CH2, CHO. So this is what you are called aldol. Okay, this is an aldehyde functional group. This is an alcohol functional group. So why it is called as a beta hydroxy aldehyde is, So this is the functional group. This is your alpha carbon. This is your beta carbon. To the beta position of the functional group, we have a hydroxyl group. So that is why it is called as beta hydroxyaldehyde. IUPAC name can be said as, this is first carbon, second carbon, third carbon, fourth carbon. So it is 3-hydroxy butan 1-al. 3-hydroxy butan 1-al. So this is the general reaction. See, as per our key, when this mechanism have been asked in the 5-mark question, this general reaction carries 2 marks. So we must make sure that we are writing this general reaction properly. Okay. Then followed by this mechanism. See, the mechanism includes 4 different steps actually. The step 1 is formation of carbon ion. Step 1 is formation of a carbon ion. Let me take one aldehyde, which is CH2 HCHO. One of the aldehyde I have just taken. See, the reaction happens in the presence of a base. So obviously, this OH will abstract this hydrogen and goes as H2O, will remain in the solution itself. This bond will shift over the head of the carbon and remain as a negative charge. So thereby your product is CH2 minus CHO. So this is what the thing called carbon ion. The first step involves the formation of the carbon ion. Okay. So since the reaction is carried out with the presence of a base, the base will abstract the hydrogen, alpha hydrogen. Thereby the negative charge shifts over the carbon, alpha carbon. It forms the carbon ion. The second step. The step 2 includes the attack of carbon ion. Attack of carbon ion. See, let me just write this aldehyde by splitting it out. Double bond O. Then we have got the carbon ion, which we have got in the very first step, CHO. What happens here? There a new bond is formed between this 2 carbon. So oxygen, this valency becomes 5, so this bond will shift and exist as a negative charge over the head of the oxygen. So to write CH3, C, H, CH2, CHO. Then on the right side we have O minus. So this is the very first one. So step 2 is the attack of carbon ion. Then the third step is proton abstraction of the proton from the water molecule happens here. Okay. So step 3, just I will write as a protonation. So to write CH3, CH, CH2, CHO, then here it is O minus. So the water molecule that has gone out in the very first step will remain in the solution. This oxygen will donate its electron and take this hydrogen. Thereby, initially we have taken OH minus from the base, so we are giving it back. So your product is CH3, C, CH2, CHO, then here it is H, here it is OH. So this is your aldol that has been formed. We have written in the general reaction. Okay. The aldol that has been formed is quite unstable, which loses water molecules so easily. Readily it loses a water molecule and forms an alpha beta unsaturated aldehyde. This is a plural aldehyde. Formation of alpha beta unsaturated. Okay, see, let me write C H, OH, then CH to CHO. I'll just split it and write CH to CHO. See, this is quite unstable. So obviously hydrogen will go as H plus, this bond will shift and form a double bond between carbon and the carbon. So valency of this carbon becomes 5, so OH will go as H2O. So H2O goes out, then we have got CH3, CH, double bond CH, single bond CHO. CH3, CH, double bond CH, single bond CHO. So this is what alpha beta unsaturated aldehyde. Why it is alpha beta? Between alpha and the carbon they have a double bond. So that is why it is called as an alpha beta unsaturated aldehyde. We call it as a croton aldehyde. Or IUPACly we call it as 2N. So this actually, see, this aldol condensation happens between two same aldehyde or two different aldehyde or between aldehyde and ketone. So when it happens with ketone, we call it as a ketone condensation. Okay. So the product contains alpha functional group and the aldehydic functional group. That's why it is called as an aldol. Formaldehyde will not undergo the aldol condensation because it does not have an alpha carbon itself. So it cannot have alpha carbon. Acetaldehyde has alpha carbon, so it cannot. Reaction happens. Okay. The very first phase, the chain reaction includes one of the proton of the aldehyde will solvent turns as COH, thereby CH2 will form bond with the carbon, which results in the formation of. This is the reaction. Therefore, includes the formation of the carbon ion by the abstraction of the proton by the base. And step 2 includes the attack of the carbon ion to the other aldehyde. Then the third step includes the protonation from the water molecule that has been gone as a byproduct in the very first step. Then the last step includes the formation of an alpha beta unsaturated aldehyde. Since the aldol compound is less stable, so that's the reason. So this is regarding this condensation. This has been taken